Time to continue to work on the flame lantern project. So I'm not going to show any of the construction of the inside of the case because there's not really going to be anything interesting to see. All I did was I took that battery from the previous section, put a strip of Gorilla Tape on it, and slapped it into the back of the case. And I actually currently have that battery charging using a different charge controller that I bodged some alligator clips on for testing battery capacities. But it's interesting to note that in the last part I messed up and I soldered the wires in the wrong polarity. So I've got my red wire on the minus and the black wire on the positive, so I'm going to have to remember that when I'm putting everything together. But for now, we need to start preparing this piece here. I've also got the charge controller board that I've already removed the USB connectors off of because that was an arduous process. I destroyed one board trying to do it and almost destroyed this one and definitely destroyed the connectors. It involved a lot of profanity, frustration, and burning myself several times. So it wasn't really the filmable material. So for now, we're just going to start working on preparing this. I'm going to fix the focus a little bit here. Actually, I don't want it to focus on that. I want it to focus here. There we go. So I'm going to go ahead and get started with that. Now that's going to be a fairly simple process. Just going to start by desoldering the battery tabs here. So I'm going to start by desoldering the battery tabs here. There we go. Flick off some of the extra solder. Ow, 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 that was still molten. And flick off the battery tab there. I may need to extend this wire depending on how I end up doing this. But then I'm just going to flip this over and pull these out of the bottom. Now the only other step that I've done off camera was drilling a hole here for the USB cable that's going to be charging the battery. So I'm just gonna, forgot to straighten these out before I try to pull them out. That would always help. So I'm just gonna go ahead and pull these out. There goes that one. This one might be a little more challenging. Nope, oh, there it goes. It comes right out. Just because I don't want them to be in the way, and you know, it's not going to be powered by C batteries anymore, so why bother? Alright, so the next step is to feed the USB cable through. Now I've got a USB cable right here. It's just an old micro USB cable, which don't get much usage in this house except for charging PS3 controllers, but we've already got a couple of those out in the living room. So I'm just going to sacrifice this one. So I'm going to nip the end of that off. And I'm going to strip a little bit of the insulation off here. How much do I want to take off? Let's take off about that much. Just score. Now, when you're working with multi-core insulated wire like this, the outer core, you're just going to want to score it with your wire strippers, and then you just kind of bend it until the outer insulation breaks, and then you pull it off. Now, this one has 4 wires because it still has the data ports on it. So I'm just going to cut the data wires off. That's, I should actually probably test which of these is which, shouldn't I? Do I have a battery bank on hand that actually has some charge to it? Do you have any power? You do have power. Excellent. So we're going to plug that in, and we're going to test to make sure I know which wire is which. I'm assuming it's the red and white wires because that's pretty standard, but I guess it's better to be safe than sorry. So I'm just going to carefully strip off a small section of the insulation on those wires. Grab the multimeter. I won't worry about getting it into shot. I'm just going to have it off to the side here. And I suppose I could also test it with an LED, but I'm gonna do that, turn it on, and maybe it isn't the red and white wires. Maybe it's red and green. That would be a little weird. Maybe this isn't staying on long enough for me to actually read anything. I wonder. Give me a second here while I test something else off camera. Found a random LED in the trash. Not too sure why it was there. But this is going to be irrelevant in just a few moments. Do you actually work? You don't actually work. That's probably why you were in the trash. So I'm going to grab a different LED here. Pardon me as I almost throw my soldering iron on the floor. That's what that weird exclamation I just made was. So what I'm doing off screen here is I have my meter set to continuity, and yeah, there we go. If you want to test if a LED is working, you just set the LED or the meter to continuity and put the LED across the leads. So this may not end up being an easier test either, but let's just give it a try. I'm gonna try to. There we go. Okay, so I guess we can pretty definitively say it's not the red and white wire, so it's maybe the red and green wire. Where's my wire strippers? Should have done all this testing off screen, but whatever. You guys can entertain yourselves with me flailing about trying to figure out which of these wires is positive and negative. So turning it back on. Still not getting a reading. You know what? I'm going to stop using this one just because I don't think I'm getting a steady power output on it. And instead, I'm going to plug it in over here to a power supply that's always on. There we go. So, we'll put the LED across the red and white wires. And not getting anything. Let's try the red and green wires. Nothing. That's weird. Looks like I may have to test this one very thoroughly. There we go. Just trim that one off. Maybe the cable is bad. That would be weird though. So, just give me a second here. If this drags on too long, I'll just start the video over again and try it and do the troubleshooting off screen. Okay, where's my multimeter again? There we go. Put it to volts. Okay, it was the red and white wires. Okay. I should have just gone with my instincts. Alright, so now that we know that it's the red and white wires for sure, and the red is positive, I'm just going to trim off the blue and green wires right here at the end. Just snip that one off, and then I'll nip the blue one off just a little bit longer to keep them from shorting against each other. And then I'm going to tin, sorry I'm doing all sorts of stuff off shot here, and I'm going to tin these two wires in preparation of soldering them onto something in a few moments. Oh, and always be careful where you set your soldering iron down. But otherwise you'll end up melting the handle of your fairly decent diagonal cutters. Alright, so just get some solder onto that. That's a very hungry wire. Really wants lots of flux. There we go. So that's soldered into place. And now, or it's not soldered. Ah! I knew I was going to do that one day. I don't know if I've done it before, but I just did it again. If I've done it before. Anyway, let's feed the USB cable in through this hole that I drilled earlier. It's one of the things I did not on camera. And then I'm just going to tie a knot in the wire here, like so. And that is going to act as a strain relief. Now the reason I'm doing it this way is because I want to be able to take this cable, and it's going to get all bundled up inside here, and then the battery compartment cover is going to go back on, so that the charge cable is actually stored inside the actual unit. I don't have any hot glue, but I'm going to put some hot glue in here once I get a dollar store hot glue gun. So the next step is to solder the voltage input onto this little charge controller board. And that is going to be accomplished. Yeah, I'm going to do that. I'm going to drill a hole for the LEDs so that you can actually see the charge status inside the thing there. But I'll do that in a moment. Actually, I'll do it now. That way I can use that as a reference for placing the PCB, which I'm probably going to try to put it like somewhere in here-ish. So if that's there, give me a second. If that's there, those wires are going to be about there, so I want the LEDs to be right about where that little mark is there. So I'll just quickly drill a hole. I wasn't planning on having the charge LED status, or charge status LEDs visible, but why not? Alright, now, I've previously marked this board while I was taking it apart and trying not to destroy it with the polarities of the wires on the connector. I'd thought about using a micro USB cable and just not removing the USB connector, but I couldn't find any micro USB cables that were of a useful length for the project. So I ended up just removing it so that I could solder this one on. So that's pre-tin. Gosh darn it! That's my third burn today. Fourth? Third? Seventh? I don't know. Ow. Maybe I'll start being known as the YouTuber who constantly burns himself on his soldering iron. Wouldn't that be a prestigious thing? Said with complete and total sarcasm in his voice. Alright. Just going to trim these down so that they're a slightly more practical length and won't accidentally short themselves out on... Is it still plugged in? No, it's not. Okay, good. And they don't accidentally short themselves onto positions in the board. So... Sorry, I was just doing a little bit of mental processing there for a second if you're wondering why I shut down for a moment. So I was pre-planning some of the craziness I'm going to have to do with the wires. So with USB connectors, the outer pins are always the voltage connectors. Now depending on the orientation of the connector, that didn't solder on at all. Depending on the orientation of the connector, the positive will either be the leftmost or rightmost position, but I always recommend that you go online and look it up to make sure, and then mark the board with the correct polarity before you start working on it. Saves you a lot of trouble in the long run. Now, if you would please solder onto the board. There we go. And we'll solder the negative lead on. There we go. Are those actually? Excellent. Okay, good. Ow, that burn is starting to really hurt. The problem with soldering iron burns, they seem to have a much more pervasive pain than most other burns. Now, the output of the board is going to be on the bottom here, and that is going to go over to this little buck converter. Now I thought about just dropping the voltage using like a resistor or some sort of current control circuit, but I ordered a bunch of these cute little buck converters on eBay because I thought they would be fun to play around with, and when they arrived I was like, hey, I will use that to be the most efficient way of taking, the 5 volts out of this and bringing it down to the 3.1, 3.2-ish volts to run the machine. I had considered just running it directly off the battery, but I didn't want to drag the battery down too far, and being as this is this device is mostly a resistive load, it would drain the battery down until the battery hit 0 because of the motor. And I don't want to do that because that's bad for lithium batteries. So the battery protection board would help with that, but the battery protection boards are only meant for extreme circumstances. So it's not, you don't want to use a battery protection board to determine when your battery gets itself shut off. So I have that there for safety, but then I have this here because this shuts off before the battery is at a voltage level that would cause it to become damaged. So it's a double layer of protection. And then of course the buck converter here, they're like 98% efficient, so I'm losing far less power using the buck converter to bring the 5 volts down to what I need than I would if I was using resistors or a current control kind of thing. So it seems unintuitive at first, but in the long run it makes more sense. Anyway, I'm out of time for this particular video because I spent so much time faffing about with this stupid wire. So we're going to cut this episode off here. If you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube thinks you'll enjoy. Right here is going to be, I guess, the playlist for building this thing. And right here is a link to Patreon that you can use to help me buy more gubbins to do things on the channel. So thanks so much for joining me, and see you in the next part.